Hello, and welcome to the AI Research Roundup. I am Alex, and today is May 13th, 2025. We are looking at a research paper from Hugging Face's trending list, published just 5 days ago, titled Perception, Reason, Think, and Plan, a survey on large multimodal reasoning models. This paper surveys large multimodal reasoning models, or LMRMs. These are AI systems integrating diverse data like text and images to perform complex reasoning. It discusses their evolution and the quest for deeper understanding and more proactive, goal-driven, what we call agentic behavior in AI. Alright, so figure 1 here really maps out the evolution of these models. It shows a 4-stage journey, starting with perception-driven modular reasoning. Then, stage 2 is language-centric short reasoning, often seen as more reactive System 1 thinking, which brought in techniques like multimodal chain of thought, or MCOT, a method helping models explain reasoning across data types. Stage 3, language-centric long reasoning, pushes towards more deliberate System 2 thinking. And finally, the proposed future, next-generation native large multimodal reasoning models for truly integrated multimodal intelligence. Alright, following that 4-stage journey, figure 3 here then provides a really detailed taxonomy, essentially a classification system of these large multimodal reasoning models. You can see how each stage we just discussed, from perception-driven to native multimodal reasoning, is broken down into more specific approaches and even example models. For instance, stage 2, language-centric short reasoning, includes methods like retrieval-augmented generation, or RAG, a technique where the AI model retrieves relevant information from a knowledge base before generating its response, making answers more factual. This visual really highlights the diverse research pathways. Okay, building on that detailed classification, Figure 5 zooms into recent developments. The top shows a timeline with models like GPT-01 from late 2024, part of Stage 3 progress. The bottom details core components, like structured reasoning and reinforcement learning algorithms. Reinforcement learning is where an AI learns by maximizing rewards. This figure highlights methods like direct preference optimization, or DPO. Direct preference optimization aligns models with preferences using a policy model, the AI's decision maker, and a reference model for comparison. It also shows rule-based reward models, applying predefined rules for feedback, all pushing towards more deliberate, System 2 style reasoning. Okay, so to really test these advanced reasoning capabilities we have been discussing, Table 7 here provides a summary of various benchmarks. These benchmarks, they are essentially standardized tests for AI. You can see it lists numerous agentic benchmarks designed to evaluate that proactive, goal-driven behavior we talked about, and also omni-modal benchmarks. These omni-modal tests assess how well models can understand and reason using many different types of data all at once, like text, images, audio, and video. Ultimately, these benchmarks help pinpoint the current weaknesses in large multimodal reasoning models. Following on from those benchmarks, Table 8 here gives us a snapshot of recent agentic and omni-modal models, all pushing towards those more advanced, native large multimodal reasoning models. It details specific models, their size, the input and output data types they handle, like text, image, or audio, and their training strategies, such as supervised fine-tuning, or SFT, where models are refined on task-specific datasets with known answers. The table also lists tasks these models perform, including visual question answering, or VQA, which involves answering questions about images, optical character recognition, or OCR, essentially reading text from images, and automatic speech recognition, or ASR, which transcribes spoken language. This really highlights current capabilities. So, after seeing the current state of these models in Table 8, Figure 9 here really sketches out the future vision, what are termed native, large multimodal reasoning models. You can see these models start by taking in diverse real-world data, images, audio, even sensor inputs, unifying all that perception. Then, the core model itself is designed for deep omni-modal understanding, that is, grasping all these data types together, and generative reasoning, which involves creating coherent outputs and even long-term plans. This all leads to the AI performing multimodal agentic reasoning, actively interacting with and learning from its environment. So, this vision of native large multimodal reasoning models really points to where the field is heading. Throughout our discussion, we have seen how large multimodal reasoning models, which aim to integrate diverse data like text, images, and audio for complex reasoning, have evolved. A key takeaway is the shift from language-centric approaches towards truly omni-modal systems that can understand any data type and exhibit robust agentic behavior, proactively interacting with the world. It is a fascinating look at AI reasoning. Thanks for tuning into AI Research Roundup.